Hey, I'm Steve, and I'm going to show you some of the cool things that I built to show off the new features in SimpleGPIO 1.1. So last week I got to host a little Intro to Robots class with some preschoolers, kindergartner age kids, um, and so I thought, what better way to help them learn than to have some real world examples. So I built two things. One's a little game here, and this was kind of hardware practice. If you see the colored strips of paper over here, these are kind of their instructions for where the wires go. You'll notice that the color of the wires match the color of the lines, and so they got to help plug everything in here. And the other thing we had was this little robot that I built out of Lego and motors and a buzzer. And they got to help with the software side of things, specifically the user interface and picking meaningful icons for what the different actions represented. So let me show you in a little more detail what these things are. So this is a little game that I came up with that combines some simple components. We've got some LEDs, a couple buttons, and a rotary encoder, otherwise known as a knob or a dial. And you'll get to see the code in a minute that runs all this, but I'll start it up so you can kind of see the functionality. So when it initializes, it just makes sure all the lights work, and then you're going to see some lights flashing at random. And the point of the game is to keep track of what light is flashing and push the button next to the light that happens next. And these three lights on the right over here are your score. So as I was talking about that, I wasn't paying attention, and I think it was yellow. Okay, so I get another point. I get two lights lit up, and one was red, so I push the red button. And then I get three, and the lights flash, and I win, and then we do it again. And what the knob does is it increases the difficulty. So we're going a little faster now, a little faster still. There's three different difficulty levels, but the game is essentially the same. You push the button, you pay attention, and you see if you can keep track of what does what. So it's pretty simple, pretty straightforward, but it's fun, especially for the kids that got to play with this. So yeah, let's dive in and take a look at the code. So our program.cs is really simple. We're creating a new Raspberry Pi object. That's the SimpleGPIO board class. We're creating a new game. That's our game-specific class. Over here, we'll take a look at that in a minute, and we're just running the run function, which is basically the initializer for the game. And then down here, because the game runs asynchronously, we're holding for console input. You could basically just have that be an infinite sleep if you wanted otherwise, or just some other way to keep the application running. So in our game class, we've got a whole bunch of fields that we initialize. In the constructor here, specifically want to call out this difficulty dial, which is a new rotary encoder. The rotary encoder is one of SimpleGPIO's new components that make it easy to just pop things in. The two parameters here, pin 32 and pin 31, are the physical locations of the clock port and the data port for the rotary encoder. And that allows us to then say, when we initialize the game in the run function here, we can say difficulty dial.onIncrease. So when we turn the dial clockwise, it's going to run this method, which increases the difficulty and then starts a new round. And similarly, when we turn it counterclockwise to decrease the difficulty, the field decreases and we start a new round. So that's one of the new things in the new version of SimpleGPIO. We've got these components that make things easier. There's also one for motors. There's lots of cool stuff, so check that out. The other thing that was added in the most recent version are these time-based methods for pins. So you saw that initialization before, where it lights up all the lights one at a time, and these 6 lines is how that happens. So we basically say turn the light on for half a second, and then turn the next light on for half a second. It just goes down the list. So that's a really easy way to just on off, next one on off, next one on off. All the code below I'm not going to go into. It's pretty domain specific, but you can feel free to take a look. The whole thing is available on GitHub. I will put the link in the description of the video. Cool. So let's switch over to our friend the robot here. It drives, it spins its flag, it honks its horn. Let's check it out. So if we take a look at the hardware involved, we've got our Raspberry Pi right here on the front that is run by a USB battery. We have a motor down at the bottom here that runs the wheels. And we have another motor here that you can see runs the flag up here. And both of these motors are powered by a separate battery here because they require quite a bit more current than the Raspberry Pi itself. So if we peek around the back at the wiring, we can see these blue cables here on the right are each going to one of the motors via the octacouplers in white right here to keep the circuits safe from each other so I don't fry my Pi. And this blue cable over here is going up to the black buzzer, which is hiding behind the elastic, and that is what's going to make the robot able to beep. Up top you can see the separate motor driver board there, and that's just, again, because the robot requires so much current to move forward and to spin its flag. The Raspberry Pi itself can't provide that much current. So here's the fancy remote control for the robot. It's my phone, it's running Firefox, and you can see Firefox is pointed to the Raspberry Pi on port 5000. That is just Kestrel running on the Pi. You can see we've got 3 buttons here, one to move the robot forward, one to spin the flag, and one to beep the horn. So I'm going to have it drive forward. We're going to spin the flag, and spin it again, and we'll drive forward again. So the code for the robot is super simple, super straightforward. It's your basic ASP.NET Core web application. We've got our boilerplate program.cs here. Our startup is almost the exact same as it is when you create a new project. The only difference is we're adding a singleton Raspberry Pi here to our configure services, and that means that we can inject it to our robot controller over here. And this is where literally all the code server side lives. So we've got a robot controller that handles the drive, spin, and beep functions that are posted to it from the front end, which we'll take a look at in a minute. But let's start at the constructor here. So we get our Raspberry Pi injected. We create a new motor, as I mentioned before. That's another one of the new components that is in SimpleGPIO 1.1. It takes 2 or 3 parameters. The first one is the enabled pin. If you're using a single direction motor, you just need to pass in 1 pin for that. If you're using a bidirectional motor, you can pass in a 3rd pin that will allow you to run the motor in both directions. But since we have 2 motors, each going in one direction, we've got the drive motor and the flag motor. We declare both of those, and our buzzer is just a simple pin. When we hit the drive endpoint, we're going to call this go forward method, and that just runs the drive motor for 2 seconds. Very similarly, when we say we want to spin the flag, we run the flag motor for 1 second. When we call beep, again with these time-based methods, so this one's a little more fine-grained, but basically we're turning it on for 1/10 of a second, turning it off for 1/10 of a second, and then back on for 3/10 of a second. And then that's what gives it the beep beep sound. It was pretty quick to figure out those intervals, but this allows you to do whatever you want. You could set up Morse code if you wanted to create a little Morse code device. But server side, that's it, right? So client side, we saw the UI there. Super straightforward here, right? We've got Bootstrap, we've got Font Awesome, we have Axios, all my favorite stuff. And so basically we've got a button with the arrow, and we post to drive, a button with the flag that posts to spin, and a button with the volume that posts to beep. That's it. It's as simple as it gets, and yet we can do all that fun stuff. So I have to admit that I haven't had this much fun programming in a long time. I'm really enjoying building this library for my own use as well as for anyone else who's using it. I hope that you're enjoying using it. If you are using it, please let me know either here, on Twitter, on GitHub. I would love to get some feedback. You know, how can we make this better together? Yeah, thanks for watching.